Good afternoon, everyone. Welcome back to this session of the Science Crossroad initiative. We are very thrilled to see you all here. We are very happy with the success of these events, and of course, welcome back. And thank you for being part of this journey of understanding and discovery, in which we explore different crossroads of different science and how they interact with other disciplines of human endeavor. To talk, it speaks for itself. Today we are trying to reach what we could call the final frontier, which is ourselves. Our speaker, Professor Mani Sarathy, is going to talk to us about consciousness and that very thing that defines ourselves. Professor Mani Sarathy, who needs no introduction, is professor here at KAUST in the Clean Combustion Center, and he and his team work on understanding and modeling how the chemical processes that happens inside engines in order to have a better and cleaner future. But, as I already said, today we are switching a little bit the topics, and he's going to talk to us about the mind and the self and everything around that. Please welcome Professor Mani Sarathy.
Okay, good afternoon, everybody. Welcome to this topic, which is very dear to me. It's science, yeah, of course, and scientific explorations of myself, of ourselves, of our brain, our mind, and ourselves. I'd like to first tell you that I'm going to share my views and experiences, and everything that I share with you are things that I have attempted or tried to experience within myself. A talk like this about the brain, the mind, the self, naturally includes aspects of neuroscience, psychology, philosophy, maybe even religion and spirituality. But I will avoid the latter aspects of religion and spirituality because everyone has their own beliefs, and I don't want to invoke any sensitivities. But nevertheless, you may take what I have and interpret it in your own ways. Okay, like any scientific discussion, I'll present data, methods, conclusions, but all of these are subject to interpretation. So use your own mind, use your own brain, think critically about what I'm to present to you, criticize it, analyze it. Don't accept these as facts, okay? This is for you to determine on your own if the things that I present to you are valuable to you and useful to you to implement in your daily life. Now, the talk is about science. We are here in King Abdullah's University, and I think a very righteous person gave us this gift of a university, a gift that allowed us to endeavor to be the most righteous of people, as the Prophet Muhammad said, who brings a greater good to the community. And I think this is the aspiration of all of us. But obviously there's hindrances that make it difficult for us to achieve this. And much of that is related to our own understanding of ourselves. And of course, King Abdullah wanted this to be a house of wisdom, a beacon of peace, hope, and reconciliation, because the Quran told that God created mankind in order for us to come to know each other. And how can we know each other unless we know ourselves? And a great institution like this, a great program like the Science Crossroad, I think that's the objective, for us to know ourselves, for us to know each other. Now, I thought this talk is about science. Science follows certain formalities. The first formality is the raising of a question. Following that is some background literature survey and research. After that, one formulates a hypothesis. That hypothesis is then followed up with some experiments and tests, which include certain types of methods. And finally, some conclusions are drawn. So this is a scientific talk. The talk will present exactly as I mentioned, starting with questions, some background research, hypotheses, methods used for really studying things in a concrete manner, and conclusions. So we'll start at the beginning. I ask you all, take a moment, take 20 seconds. What question do you want answered? What do you think is the most important question? Now tell it to your neighbor. I want you to tell your neighbor what you think that question is. Okay, it was just one question. That's all I asked for. You had a question. I assume the question was related perhaps to the topic at hand. Perhaps not. Nevertheless, you guys have a question. Some questions I intend to try to understand in myself is, what is life? Who am I? What am I? What is my brain and how does it interact with my mind? How do these things give me a perception of reality? And how does this influence my daily behavior? We'll come upon many questions, but first the brain. If we ever want to start to understand ourselves, we need to understand our physiology. This is the typical construct of the brain. The brain is often said to be consistent of three parts. The very oldest part is the reptilian brain. It's a part of the brain we share with many creatures, all other creatures, even reptiles. And it controls many of our things like instinct, dominance, and survival. Then you have what we call the old mammalian brain, or the limbic system. And this is where we hold a lot of our memories, feeling, and emotions. And the newest part of the brain is what's called the neocortex, or the human brain, the new brain. And it's what really distinguishes us humans from other types of life, other types of mammals and reptiles. As Professor Duarte mentioned in his first talk of this Science Crossroads, the human brain is much like the dolphin's brain. We are the two most evolved neocortices, the largest brain in proportion to the rest of the body. And he went on to talk about a theory of how humans and dolphins evolved together. I won't go there, okay? Nevertheless, this is our basic concept of the brain, three different parts. The newest part incorporates language, ideas, concepts, artistic visions. And in the past, people tried to understand. They dissected human brains. They found out these different parts. They dissected animals. They found the different parts. But then they tried to understand, are certain parts of the brain really responsible for certain types of behaviors, actions, motor functions? And indeed, around 1888, there was a young man around the age of 30, Louis Victor Lebrun, who suffered a stroke. And he went to the hospital, and he went to a doctor and a neuroscientist at the time, Broca, Pierre-Paul Broca. And this man, after his stroke, he could only say one word, and that word was tan. He would say tan, 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 tan. And eventually he got the name Tan. For about 30 years he lived, and he passed away at the age of around 60. And when he died, Dr. Broca dissected his brain, and he found a part of the brain which suffered a lesion. And that part was in the neocortex, somewhere in this region. We'll see a more focused image on that. And they called that the area of the brain responsible for speech. And it was the first time that somebody had said a part of the brain is responsible for some type of behavior or action, and that was speech. Because everything else he could do fine. He could move his hands, he could move his legs, he could he could think properly. He just could not speak, and the part of the brain that was suffered was this what they call the Broca's area, the area responsible for speech. Indeed, that was the first time, in addition to dissections, people come to understand what is really there in the brain. Of course, there's biology in the brain and chemistry in the brain. The basic material of the brain, you could say, are the neurons. And as Professor Magistretti, our brilliant scientist, will say, we also have the astrocytes, the other half of the brain, the forgotten half of the brain. So if you want to know more about these aspects of the brain, please see his web talk. I won't go into great details, but we have these neurons. These neurons are connected together in all parts of the brain. And we typically call a presynaptic neuron as one that fires, sends a message by an electrical impulse. And then that electrical impulse is sent down to the end of an axiom, and the charge or the electron transfer has to be transferred to the next postsynaptic neuron. And as this charge is transferred, the brain creates its networks. Connections are made. And we know very well, you may have heard these things like neurotransmitters. These are chemicals that are emitted in the axiom to transfer the charge to the next neuron. And like this, the neural system is built. And there's different types of neurotransmitters. You may have heard of words like dopamine, serotonin. These are responsible for creating those connections. And indeed, much science has shown and much research has shown that certain activities, certain behaviors promote the release of certain types of neurotransmitters, while other activities, such as the taking of drugs, alcohol, certain types of behaviors, actually hinder the production of certain types of neurotransmitters in their natural state. But this is all pretty much understood from biological and chemical aspects. The real advances in brain understanding have come in about the last 20 years. And these are based on different methods of imaging the brain. We know the brain is made of neurons. We know that these neurons are firing. And if you can study this in different local regions of the brain, you can start to understand different processes of the brain. So one common one is functional magnetic resonance imaging, about 25 years old. They typically, in the brain, as the neuron fires, it requires blood. So you try to measure how much blood oxygen demand is there in certain regions of the brain using the magnetic resonance imaging. And as different neurons start firing or become active, they can identify, and we'll see examples of this, which regions of the brain are really active. It's a good technique because it's very location specific. You can get to within a few millimeters. But it's not time resolved. It's about half a second or a 1 second delay. So you can't get really good time resolution. But as you'll see, much of our brain activity and mental activity is very time resolved, on the order of milliseconds. And then you have EEG, electroencephalography. This is where they put electrodes on your head and they measure electric signals being emitted by the brain. Good technique for measuring electrical signals. Very time resolved, very quick, but not location specific. Because these electrical signals are kind of diffused by all the tissue and the surrounding mass. You really don't know where they're coming from. More recent is magnetoencephalography, where you start to use magnetic signals coupled with electrical signals. And like this, you can get now time resolved and location-specific information. And this has really brought a lot of advances in our understanding of the brain. Neuroscientists use these techniques. They try to get subjects to undergo different types of behaviors and actions, and then see what happens in the brain. So as we mentioned, this brain has different regions, and Broca was the first to identify this area, which is the production of speech, but there's many other areas. We have the visual area, the visual association area, the visual cortex, things related to understanding of speech, the auditory cortex, things related to sound, somatic senses, touch and taste, and your motor cortices. And all of these are relatively well mapped out, but as we'll see, even this very basic segregation of different parts of the brain is not so well defined and so definite. So we're going to watch different videos along the way, okay? And of course, sometimes it's best to see some of the best speakers in the world talk about this type of advances in science. So this is Nancy Kanwisher, about a 3-4 minute TED Talk clip on her experience and knowledge from brain imaging.
So to do this, I've spent a lot of time in the scanner over the last month, so I can show you these things in my brain. So let's get started. Here's my right hemisphere. So we're oriented like that. You're looking at my head this way. Imagine taking the skull off and looking at the surface of the brain like that. Okay, now as you can see, the surface of the brain is all folded up. So that's not good. Stuff could be hidden in there. We want to see the whole thing. So let's inflate it so we can see the whole thing. Next, let's find that face area I've been talking about that responds to images like these. To see that, let's turn the brain around and look on the inside surface on the bottom. And there it is. That's my face area. Just to the right of that is another region that is shown in purple that responds when you process color information. And near those regions are other regions that are involved in perceiving places. Like right now, I'm seeing this layout of space around me, and these regions in green right there are really active. And there's another one out on the outside surface again, where there's a couple more face regions as well. Also in this vicinity is a region that's selectively involved in processing visual motion, like these moving dots here. And that's in yellow at the bottom of the brain. And near that is a region that responds when you look at images of bodies and body parts, like these. And that region is shown in lime green at the bottom of the brain. Now, all of these regions I've shown you so far are involved in specific aspects of visual perception. Do we also have specialized brain regions for other senses, like hearing? Yes, we do. So if we turn the brain around a little bit, here's a region in dark blue that we reported just a couple of months ago. in this region responds strongly when you hear sounds with pitch, like these. Okay? In contrast, that same region does not respond strongly when you hear perfectly familiar sounds that don't have a clear pitch, like these. Okay. Next to the pitch region is another set of regions that are selectively responsive when you hear the sounds of speech. Okay, now let's look at these same regions. In my left hemisphere, there's a similar arrangement, not identical, but similar, and most of the same regions are in here, albeit sometimes different in size. Now, everything I've shown you so far are regions that are involved in different aspects of perception, vision, and hearing. Do we also have specialized brain regions for really fancy, complicated mental processes? Yes, we do. So here in pink are my language regions. So it's been known for a very long time that that general vicinity of the brain is involved in processing language. But we showed very recently that these pink regions respond extremely selectively. They respond when you understand the meaning of a sentence, but not when you do other complex mental things, like mental arithmetic, or holding information in memory, or appreciating the complex structure in a piece of music.
So it's very clear. Now, this is about a 50-year-old counter, and you can find thousands upon thousands of papers of people doing brain imaging to identify different tasks, different processes that are happening. And just to make it clear that indeed these parts of the brain are really responsible for certain types of tasks, this was a very nice experiment. We'll be doing several experiments. This was an experiment done in Stanford University where a patient had suffered epilepsy, and a 46-year-old patient, and they had put some electrodes in the brain because a common way of treating epilepsy is to put some electrodes to minimize electrical stimulation in the region. So they had put some electrodes in the part of the brain, and this just happened that the part of the brain where they put these electrodes were very close to where the part of the brain were responsible for face recognition. So what Dr. Parvizi did is he put the electrodes and he started to activate them, and we'll see what happened.
Just look at my face and tell me what happens when I do this, all right? Okay. 1, 2, 3.
Nothing.
Nothing? Okay. I'm going to do it one more time. Look at my face. 1, 2, 3.
You just turned into somebody else.
Tell me
Your
about
face metamorphosed. Your nose got saggy, went to the left. You almost looked like somebody I'd seen before, but somebody different. That was a trip.
So it's very clear. Physical stimulation of certain parts of the brain will create some change in visual perception, visual attention. These things are facts, and these things are well known nowadays. You can put electrical stimulation. But nevertheless, parts of the brain, as fMRI showed us, are responsible for various types of motor functions, behaviors. But that's not enough, okay? We're not just motor functions. We're not just the senses. We're not just hearing. We're much more complex than that. And the next question is then, this is a physiological behavior of our mind. We have neurons, astrocytes. There's chemical interactions. There's neurons that come alive during certain types of actions and certain types of attentions. But we always feel that we are not this brain. And it's a common philosophical thought for thousands of years now is that I am different than this brain, that the mind is something different than the brain. So let's try to understand what is the mind and what is, again, what has neuroscience taught us about the mind? What has brain imaging taught us about the mind? This is a very nice experiment by Leibniz in 1983. He wanted to study this aspect of consciousness, awareness. We always think we're responsible for our actions. We are free to do whatever we want. So Leibniz made an experiment where, again, he put some electrodes on the brain, and he asked the subject to move your hand, and tell me when you're going to move your hand, and we'll record some brain signals that are associated with that motor movement. And it was very interesting. What he found is that that conscious wish or that alertness, we can say, that instruction to move the hand came very late. Actually, other parts of the brain became much more active, several thousands of milliseconds, even before the subject had a conscious awareness that he wanted to move his hand. Now, how is that possible? We also think, I want to move my hand, I'm moving it. But what Liebig showed is there's parts of the brain which have already decided that you're going to move your hand, even before you think you're going to move your hand. And he went on to say, and then a lot of philosophy of free will and things became very controversial. So he said this is not necessarily a bad thing, because what he found is that this conscious awareness of something happening still preceded the action by about seconds. So he said that conscious awareness is like a veto power. He called it free won't. Actually, we are aware, once that an action is going to happen, you can stop it. And you can either allow it to go or you can stop it. And so awareness plays a very critical role. It's not like things are just happening and we let them happen. We have no control of it. No, the awareness says that things are going to happen. If you're aware that it's going to happen at the right time, you can stop it. And more recently, this is Nature Neuroscience, a paper by Sun et al. They do this with now brain imaging, more advanced techniques, again, ask people to do certain motor functions and image parts of the brain. And more, this is very fascinating. They said even 10 seconds before the awareness, 10 seconds, there was portions of the brain, prefrontal and parietal cortex, which were active. The subject has no idea even what he's going to do. 10 seconds prior to that, there's already brain functions associated with that movement. And again, very fascinating. These are very high-resolution studies to determine what happens 10 seconds before. But nevertheless, it says that things are always happening in the brain. And what we think is consciousness, modern neuroscience will say 90% of consciousness is actually unconscious. So things happen in the body, things happen in the brain, mind acts, but a lot of it is happening without our awareness. So our awareness is not our consciousness, is the message. And our awareness cannot be who we are. It's just one part of who we are. But many other things are happening in the background which determine the daily course of our actions and our behaviors. Okay, well, we'll see how awareness and attention really are subject to how you perceive a certain situation. So this is an experiment. All of you will participate in this experiment. I'm going to play the video, and there's a white team and a black team, and you're going to tell me how many times the white team passes the basketball.
This is a test of selective attention. Count how many times the players wearing white pass the basketball. How many passes did you count?
Okay, 15, 16, 14. Okay. It was hard. I got hard in a bit. But who saw the gorilla? Some people saw a gorilla. Who didn't see a gorilla? Watch it again. Pay attention. So there's a gorilla, right? There's a gorilla in the video. Now the fascinating thing, they called it attentional blindness. This was a video from Simon and Chabris, Perception, 1999. And inattentional blindness means you think you're looking at something, you're so focused on it, but you're not aware of the other things. They don't reach your attention. They don't reach the level of your awareness. But the real fascinating part of that is that the brain did see the gorilla. If we were to put your mind, your the parts of the brain related to recognition of other beings, other people, would have been activated. It saw the gorilla. You just didn't realize it at the level of your awareness. Very fascinating. And that was, again, what Beck et al. In Nature Neuroscience showed, that we look at things, certain things we raise our awareness to, but the brain is always alert of many other things that are happening. And we filter them out. We don't even notice them. So we conclude that conscious detection visual changes rely not only on regions of the visual cortex, but again, when I told you to look for the gorilla, your prefrontal cortex started to expect there to be a gorilla, and then it brought it into the level of your awareness. And this goes even, it has broader implications. So this is some recent study from Owen et al. In Science about 10 years ago. A vegetative patient is a person who is just came out of a coma, but they're not responsive to any extrasensory impulses. So you touch them, you talk to them, they don't respond. They're in a vegetative state. And it's very difficult to diagnose this type of condition. But what recent studies have shown is a person in a vegetative state, seemingly a vegetable, not be able to understand anything, comprehend anything, they tell the subject, imagine you're playing tennis. Imagine you're walking through your house. And they use the brain. And they found that the motor areas involved with tennis or movement are the same as in a person that's healthy and awake. So the brain is even active, and it's processing things at a subconscious level, the same way in which a regular conscious person is doing it. Same thing with spatial navigation. Spatial navigation imagery shows this person, their brain can still process, even though they're not aware or alert or conscious as we conventionally think of it. Another interesting one is the rubber hand illusion. I won't show any video of this, but you can think about this illusion. You could do it at home as well. And what you do is you take your hand, and I put it on one side of the box, and I put a rubber hand here that looks kind of like my hand. And then the patient, the scientist brushes your real hand with a paintbrush and brushes the rubber hand with a paintbrush as you look at it. And very quickly after 5 or 6 brush strokes, the subject starts to feel like the brushes on the rubber hand are really their hand. So it's quite now and well understood that the brain and the mind adopt a fictitious hand as itself. As long as the sensory connection suggests that visually this is my hand, and initially priming it, feeling that there's brushing on the other hand, there's brushing on my hand, it's the same. And then the funny part is they take a knife and stab the rubber hand, and the person pulls their hand away. So you can try it at home, do it with your friends sometime, and they really feel like a knife is puncturing my hand. And this was published in Science for the first time more than a decade ago. And the interesting part is, they showed that, you have the premotor cortex, you have this ownership of the hand. And we always have this feeling, right? We feel we own something. We feel we own our body, we own our brain, we own our mind. But we also feel we own other things. I own my computer, I own my pen, I own my car. Things that are not even ours. Yeah? Same thing, that's what the rubber hand illusion says. It's very easy for the brain and the mind to adopt something as our own, even though it's not really part of our physiology or our existence. And then more recently, a very interesting experiment in neuroscience from the same team. Instead of just rubbing one hand, they told the user touch the rubber hand, and they also touch their own hand. And as they touch the rubber hand, now they're combining motor movement of one hand and sensation in the other hand. And they found that even then, very complex parts of the brain associated with touch and motor movement really thought that that rubber hand was the real hand. One of the most fascinating things, and this was all discovered by a doctor named V.S. Ramachandran in UC San Diego in a book called Phantoms of the Brain. We'll watch a short video. He was a doctor, a medical doctor, and what he would do is he would deal with amputees, patients which had lost a limb. And patients would come to him and say, I lost my arm, but I still feel my arm. There's so much pain there. And he was trying to understand why, this person has no arm. The neurons are gone. The whole thing is gone, but still they feel it. And more interestingly, as you'll see, one subject, they would brush the person's face. And every time they brushed the person's face, he said, every time he's shaving, he said, I feel it in my arm, my phantom arm. And he tried to understand what's really happening. And fascinating discoveries in neuroscience came about by this. the concepts of body image and neuroplasticity. So this is also a few minutes, we'll see, a dramatization of this.
The first thing Ramachandran did was to invite Derek to his lab for a simple test.
Derek, I want to touch different parts of your body, and I just want you to tell me what you feel and where you experience the sensation, okay?
Okay.
Close your eyes.
He touches Derek's forehead with a Q-tip.
You could feel that on my forehead?
Anything anywhere else?
No.
Okay.
It's on my nose.
Okay.
My chest.
Your chest. Okay.
He touches his left cheek.
I can feel that on my cheek, and I can feel rubbing on the phantom left hand.
On the phantom left hand, in addition to your cheek, I'm going to run the Q-tip across your jaw and see what happens.
I can feel a Q-tip on my cheek, and I can feel a stroking sensation across the phantom hand.
You actually feel it stroking across your phantom hand, across the palm. So here is a medical mystery of sorts. Why does this happen? Why would a person, when you touch his face, claim that it's also touching his missing phantom fingers? That's fine. Thumb and palm.
This was just the kind of mystery that Ramachandran was drawn to,
Now in Derek's driveway.
although it would take some time to solve. One day, while Derek was making one-armed repairs on his favorite Chevy, Ramachandran turned up with his solution. It was a groundbreaking theory.
The reason we think it happens is that in the brain there is a complete map of the surface of the body. The entire left side of my body, the skin surface, is mapped on to the right side of my brain along a vertical strip of cortex, which we call the somatosensory cortex. Similarly, the right side of my body is represented on the left side of my brain.
Animation shows the somatosensory cortex as a strip across the top of the brain.
So every point on your body surface has a corresponding point on this body map.
On an animated brain segment, a face lies beside a hand.
Now it turns out that the representation of the face on this map is right next to the representation of the hand. Now that's a bit surprising, as you'd expect the map to be continuous and faithfully represent the left side of my body. But it doesn't.
Back in Derek's driveway.
Now imagine what would happen if the left arm were amputated. The part of the brain corresponding to the hand no longer gets any input, and it's hungry for new sensory input, so to speak.
Computer animation.
The sensory signals from the face normally activate only the face area that's right next to the hand area, but they now invade the vacated territory corresponding to the missing hand and start activating the hand region in the brain.
So this was a groundbreaking discovery. So it says the area of the brain that's responsible for this phantom arm, or this arm, and touch and sensory perception there was very close to the part of sensory perception related to the brain. When they cut off the arm, that part of the brain had no more signaling. So what did it do? The neurons adapted. They molded, they morphed. And they started associating themselves. They entered, the regions of the face area, the sensory perception there, entered into this area which was associated with the arm. So every time they brush the face, he really feels it in his arm. And this is where the concept of neuroplasticity came from. Conventionally, it was thought you're born, and after you mature, your brain does not change. This was a conventional thinking in neuroscience, that the brain is fixed. You have your connections, you keep them for your whole life, and then you die someday. But he was the first to say, no, the brain is changing. Neurons are creating new networks, they're taking over new areas, and then, of course, now this opened up whole new areas in terms of neuroplasticity, learning, changing of behavior, changing of addiction, changing of the way you perceive things. All of it can be changed. The brain is completely malleable. It's completely plastic. And thousands upon thousands of studies are now showing this. More interestingly, he showed that therapy can resolve the situation. So the doctor could actually do something. So his next thing was he basically made the brain think that the phantom arm was real. So there was a mirror illusion that now he put the subject, like the rubber hand, he has the subject put his regular hand and then a mirror of that hand. So now the subject believes he has another hand. And the brain starts thinking, my hand is back. My hand is back. And then slowly they reduce the amount of sensory perception and slowly phase out that mirror image. And then by therapy, they're able to get rid of this strange wiring in the brain. So therapy plays a role. But individual behavior and individual action also plays a role. You can change your mind and you can change your brain. Now the self is the hardest part. We are a brain. We have certain actions. We have certain behaviors. We have a mind. This mind is aware. We're sometimes unaware. We're most of the time aware. We think we're conscious, but most of the things we do are actually unconscious. So what is the self then? Oftentimes we think of ourselves as our emotions. We identify very strongly. I am this person. I'm a happy person, a sad person. I have these types of likes and dislikes. And emotions, as a psychologist will say, are really the things that define a human being and our association with emotions. But emotions, we'll see, are also just other aspects of the brain and the mind. So Paul Ekman was a renowned psychologist. Nice book, Cognition and Emotion, in 1992. He is the first to classify that. He took thousands of people all across the world, and he looked at their facial expressions under different types of emotions, and he started categorizing the 6 basic emotions: anger, happiness, surprise, disgust, sadness, and fear. And of course, he went on even further to divide all of these into other types of emotions and slowly build a database of many different types of emotions that a person actually experiences. And nowadays, of course, we have all these emotions. And these emotions are real emotions. Any one of us can look at this picture and say, what's that about? Just looking at the face, your brain recognizes, oh, there's some facial pattern. That pattern tells me the person is exhausted. That's an emotion of exhaust. Similarly, you see almost playful, invisible. There's actually a lot of research now about the role of emoticons in the real emotions that people feel and sense by brain imaging. And why is that? It's because what emotions are really is, emotions are a combination of things happening in the older areas of the brain, the mammalian brain and the reptilian brain, but also our very modern neocortex, our new mammalian brain. And emotions are the combinations of experiences we have with language, culture, perception. And that is why modern psychologists will tell you that emotions are different in every culture. Because you might have in your culture or your language a word for the sadness you experience when you have lost something very dear to you. And in English, it's not a single word. Like this, many cultures have their own words for different types of emotions. And that's why we find it difficult sometimes to relate to another person to an emotion they're facing, because we really cannot communicate it. So emotions, they might fall into these very distinct areas. We might have emoticons and facial recognitions, but it's much more complex. It's very much tied with culture, tradition, and language. This is a 1688 medical dissertation. I guess it's in Latin. It was written in Switzerland. And it's a dissertation about a certain emotion this medical student discovered. There was a patient, another student at the University of Basel. This patient broke out into severe rash and hives, palpitations, sweating, and they went to the medical school, and the doctor said, "You're going to die. There's no, send this guy home. There's nothing we can do for him." And they sent him back home, and he was okay. He got okay in a few days. And the medical student said, "That's strange. We thought he was going to die here in Basel," and then he went back home, and he was fine in France. And he said, maybe he's homesick. Yeah? This was the first account of nostalgia, homesickness. And being here at KAUST, I thought it was an example. You guys always feel homesick. But homesickness is an emotion. Nostalgia is an emotion. And the fascinating part is the last person to die of nostalgia and homesickness was in World War I. So a lot of soldiers in European history and in the First World War used to die of homesickness. But nobody dies of homesickness anymore. It's been almost 100 years since the last person died of homesickness. And modern psychologists try to understand why that is. Well, it's that nostalgia and homesickness have become part of our culture, have become part of our language, part of our common understanding. As people grow up, they spend time away from home. They start understanding that this is a natural emotion. It's not something that should evoke a physiological response. And it's virtually eliminated from the human race. So what was perceived as a disease 100 years ago, related to emotions and physiological changes to the body, and death, no longer exists. So then it says, well, what does the future hold? For all the mental diseases we have, depression, extreme depression, addiction, will these things go away as we develop better understanding, better communication, better knowledge of how these things influence our behavior? This is a nice PNAS paper from a few years ago, bodily maps of emotions. So emotions don't just happen in the brain. The brain is connected to all the neurons through the neural networks. And they took many subjects and they developed what is called heat maps. And a red color means there's a strong influence of a certain type of energy. It doesn't have to be any specific type of energy. They just ask the subject, what do you feel? And they say, I feel more energy or less energy. And they try to image them. And then similarly, blue means a lack of energy or a lack of feeling. And they found that certain parts of the body are associated with different types of emotion. Anger, fear. Many times you feel fear. You feel your heart is just uncomfortable. Depression. You feel void. You feel empty. Now science is saying, yes, these are normal physiological experiences, and we're able to detect them, and we can map them out. So I like this paper because it shows that every type of emotion is, again, another type of physiological response that one experiences within their own body. It's nothing more. It's nothing less. And then the brain feels those feelings, those sensations. It interprets them as emotions. Those interpretations are subject to our own learning, to our own culture, to our own understanding. And they're subject to change as well. If we change the way we perceive situations, if we change the way we observe an emotion, the brain will change. Okay, we have to see this one. This is the Atlas of Emotions from Paul Eckert's daughter. This was supported by the Dalai Lama. Dalai Lama being a person who's very interested in knowing about emotions and how it influences human behavior, worked with Eckert's daughter to make this website. And it kind of showed how, the timeline of how different things happen in a human, how emotions arise, how we react to those emotions, and how it influences our behavior. Let me see if I can. So we see here. Okay, we'll just take this first example. So a friend gets angry with you. You feel anger. That physical thing happens in the body. And then you respond. You respond by arguing. And how does this happen? Yeah, they show it very clearly. You first have some trigger. The trigger is you're tired, you're hungry. Then somebody comes to you and yells at you. You're reminded that this person is a bad person. You respond with feeling more uncomfortable. And then you argue back. Okay? And all of this perception of what happens is based on what you're experiencing and also based on your previous experiences. Now what happens if you're aware? Okay, if you're aware that this process is happening. Aware of that conscious level where, again, it's very late, remember. What we call awareness comes very late. Let's see if this works. Not working here. Well, I'll tell you. Okay, you can visit the website on your own. Okay, so what happens when you're aware? Still the same process happens. You feel, you're still tired, you're still hungry, somebody comes and yells at you, you feel angry, but now the awareness gives you a veto power, right? That awareness gives you an option to argue or an option to do something else. You cannot argue. Instead, you can think, let it go. You can think, forgive this person. You're given options. You cannot change the situation that happened. Don't believe you can. That's impossible. The perception, the event has happened. There's a physiological response. But what can change is the way that the subject reacts to the situation. And that's what this whole website is about. There's many different types of emotions. And one part of it is awareness. All awareness requires is you know that an emotion exists. all you need to know. And then, again, what modern psychologists are trying to do is try to put names to all the different types of emotions. Try to give understanding. The Atlas of Emotions has now thousands of emotions for every type of feeling a person has. So that when you feel an emotion and you become aware of it, you know that this is an emotion. It's not something that's overpowering me. It's not something that's really part of me. It's just another emotion, and it's something that everybody else in the world also feels at some point. So how do these all come together now? Yeah? And that's kind of what we wanted to talk about. How these all come together, the brain, the mind, and the self. We have this physiological brain. We have this mind, which is largely unconscious, aware of a few things, but still we're able to get through our daily life. And we have this perception of self. We perceive that we're this human being. We have a body, but even that's kind of loose. Yeah? We sometimes take objects that are not our body and adopt them as our body. If parts are missing from the body, we take them as our body. So even that perception of self is something that's kind of ingrained in who we are, but it's all subject to change and due to the concept of neuroplasticity. So we're going to take a brief minute to listen to this guy, Anil Seth, who's also a neuroscientist, and he tries to understand how the brain really brings all these things together. And he says the brain is a computer. It's making a prediction. Again, most of the things that enter our brain, we filter them out. We take what we need and we make a prediction of why it's important and why it's not important. And we'll listen to him for a few minutes.
This process is one of the greatest remaining mysteries in science and philosophy. How does consciousness happen? Somehow, within each of our brains, the combined activity of many billions of neurons, each one a tiny biological machine, is generating a conscious experience, like a force of life or an élan vital. So as with life, so with consciousness. Once we start explaining its properties in terms of things happening inside brains and bodies, the apparently insoluble mystery of what consciousness is should start to fade away. At least that's the plan. So let's get started. What are the properties of consciousness? What should a science of consciousness try to explain? Well, for today, I'd just like to think of consciousness in two different ways. There are experiences of the world around us, full of sights, sounds, and smells, this multisensory, panoramic, 3D, fully immersive inner movie. And then there's conscious self, the specific experience of being you or being me, the lead character in this inner movie, and probably the aspect of consciousness we all cling to most tightly. Let's start with experiences of the world around us, and with the important idea of the brain as a prediction engine. Now, imagine being a brain. You're locked inside a bony skull trying to figure what's out there in the world. There's no lights inside the skull. There's no sound either. All you've got to go on are streams of electrical impulses which are only indirectly related to things in the world, whatever they may be. So perception, figuring out what's there, has to be a process of informed guesswork in which the brain combines these sensory signals with its prior expectations or beliefs about the way the world is to form its best guess of what caused those signals. The brain doesn't hear sound or see light. What we perceive is its best guess of what's out there in the world. Let me give you a couple of examples of all this. Now, you might have seen this illusion before, but I'd like you to think about it in a new way. If you look at those two patches, A and B, they should look to you to be very different shades of grey, right? But they are, in fact, exactly the same shade. And I can illustrate this if I put up a second version of the image here and join the two patches with a grey-coloured bar. And you can see there's no difference. It's exactly the same shade of grey. And if you still don't believe me, I'll bring the bar across and join them up. It's a single coloured block of grey. There's no difference at all. So this isn't any kind of magic trickery. It's the same shade of grey, but take it away again, and it looks different. So what's happening here is that the brain is using its prior expectations built deeply into the circuits of the visual cortex, that a cast shadow dims the appearance of a surface, so that we see B as lighter than it really is. Here's one more example, which shows...
So it's a simple example to show that we think we see a different shade of gray, but it's really the same shade of gray. And it's again our own conditioning. We think if there's a shadow, that this shade of gray must be lighter than the other shade of gray. Like this, you can say every behavior of the mind is conditioned. Let's listen to this. Tell me what you hear.
It was a sunny day in the
What did you hear? Something's weird, yeah? You hear? Anybody heard words? Okay, now listen to this.
It was a sunny day and the children were going to the park.
Now listen to this.
It was a sunny day and the children were going to the park.
Why did it happen? The first time, you might have picked out a few words or something, but some conditioning of something you understood, and then I played the same gargled sound again, and it made sense to you. And this is how consciousness works. This is how perception works. This is how conditioning works. And it's like this with everything we experience, not just the visualization of colors, not just the sound that we hear, everything we experience. The experiences we have of ourselves is similarly conditioned in the same way. And I encourage you to watch the rest of that talk by Anil Seth. It goes pretty deep, so we don't want to go all the way there today. But you can see the rest. And he talks more about how the mind also perceives the body. Autonomic functions like breathing, kidney functions, digestion. All of these are there. They happen within our body. The brain is always aware of them. They're influencing our behavior. And it's all related to how the conditioning has happened for our own survival. And this is a nice paper if you want to read it. A lot of neuroscience jargon. But he basically says that the brain is predictive. The first time you saw the visual colors, you predicted it's a different shade of gray because of the shadow. Same thing with the sound that you heard. Your brain predicted the second time that it's actually speech. So like this, the brain always makes predictions. It brings in all the information it has and it tries to predict something. The most common thing is in emotion. You meet somebody from another culture. They make some statement to you. They say some words to you, which then in all countries okay. They might make some facial expressions, but immediately you react the wrong way. This person is very rude. This person does not believe me. This person is not listening to me because their body language, their facial expressions are different. But that's your own conditioning. You're making a prediction about what that person is thinking and feeling. You have no idea. Like this, we do this all the time. Everywhere we go, we make predictions. Sometimes those predictions are false, and most of the time they're right. And when they're right, we say reality. When they're false, we say this person is crazy. Right? Okay, so how does this all come together? I told you, all of this I told you is interesting. It's fascinating. Science. It's intellectual. What I'm telling you now is, what I've shown you now are scientific papers, very renowned experts. But I got interested in this because I want to see what's happening within myself. And if you want to really understand these processes in yourself, you need to stop. Yeah, you need to stop everything you're doing, and you need to observe yourself. Because all these things are happening. But they're happening at an enormous pace. They're happening very quickly. And it's impossible to understand all these processes just by talking together in our daily lives, carrying on with normal business. So about 15 years ago, I started some practice of observing myself. You can say meditation. You cannot say meditation. It's okay. It's just a practice. And it's a practice of observing oneself. What am I? And it starts at a very simple level. What does the brain normally do? What does the mind normally do? It lives. And our life is connected to breathing. So the first thing you do is try to observe what the brain does. The brain breathes. It's involved with various autonomic functions. So I go for these courses. Some people in this room have been for these courses. You leave the normal society. You go and stay by yourself in a room for 10 days and you don't talk to anybody. You're silent. And you just observe yourself. And you start by observing your breath for 3 days. And nothing else. You're not reading books. You're not watching the news. You're not listening to anything. You just observe your own brain. Observe your own body. So the first thing is the breath for 3 days, 10 hours a day, wake up in the morning, go to sleep at night, just observe your breath, and you start to realize different things about yourself. You start realizing that, my breathing is tied with my thinking, my breathing is tied with my feelings and my emotions. Memories come up, anxieties come up. The breath always has a relationship with what's happening in the mind and the brain. But more deep than that is not only the breath, right? The body is always doing other things. It's getting hungry. It's getting tired. If a memory comes up, it gets angry. And all these things are feelings in the body. Like I showed you that heat map. You can feel everywhere in your body. And a person who has practiced in this art, or this type of meditation, can start to feel what we call sensations or feelings everywhere in the body. In the head, in the tip of the finger, at the tip of the toe, at the side of my shoulder, instantaneously. Try to feel everything that's happening in the body at every instance. Of course, it takes a long time. It takes practice. But in the course of 6 days, 10 hours a day, if you practice this, you come to the point where you can feel everything everywhere in your body. These are called physical sensations, and those sensations are tied, again, with the mind. So once you're able to feel, you start seeing. Some emotion has risen in my mind related to some past experience or past memory. If it's an emotion of anger, I start to feel heat and palpitation, and eventually it goes away. You're trained like to be a scientist. Our goal is just to go and observe what's happening so we understand what's happening in our body. And you then start to understand how this body, these sensations influence the brain, how this brain creates certain types of emotions which we think are ourselves, and then how that emotion and that perception of self brings us just more and more unhappiness. And the whole art of this type of practice is, again, if you observe yourself, maybe you can come out of the behaviors which lead to unhappiness. This is an ancient quote from India. Wonderful indeed it is to subdue the mind. So difficult to subdue, ever swift and seizing whatever it desires. A tamed mind brings happiness. And you might go home today and think, I closed my eyes, I watched Professor Mani's talk, my mind is tamed. It's not that easy, okay? Tamed mind takes a long time to train, to get tamed, okay? It takes a long time to start to feel everything in the body. But it's possible. And it's like neuroplasticity. The brain, the mind, they start to experience something different, and they make the connections required for these types of awarenesses to be realized. As you go deeper, you can start to see how different things happen in the brain and happen in the mind and how it relates to how you behave. So we know very well, science will tell us, you see something, there's sensory contact, it illuminates a part of the brain. We already saw that, visual cortex. And that I can experience as well. If I see something, I become aware of it at some conscious level. But other things also happen. You start to perceive or to lay a judgment on what you saw based on your past conditionings and past experiences. I see something that I like, I say, fantastic, great. I then start to have some type of a sensation. The neurons start firing, say, great, I like to watch this movie, it's fantastic. And you start to feel very good in your body. And what happens? Those sensations go through your whole body, your brain feels those sensations, and it starts to react. And the cycle continues. The reaction then brings up a thought of happiness. Thoughts also can become part of your consciousness. You can have a good thought, you perceive it as good, you have a good sensation, and the cycle continues. Similarly, you're angry. Somebody yells at you or shouts at you. You see that anger, you immediately get an unpleasant feeling. I always get angry at my wife. I always get angry at my kids. But it happens. This is nature. Somebody says something you don't like, you get a feeling in your body that's negative. It feels painful, and you react. And then you shout back, and then the anger continues. And then you keep perpetuating the cycle. But how does this type of practice help? Remember, we have the veto power. Yeah? That's what Libet showed. You have a veto power. If you are aware that you cannot stop that somebody comes and yells at you. You cannot stop that you became aware of it. You can maybe change your perception, but that takes time. But you can observe what's happening in your body. And if you observe something and don't react to it, then this last step doesn't happen. And then the cycle doesn't continue. And slowly, slowly, that's the whole part of this type of practice, is observe what's happening in the mind and body. If something happens which you like or you don't like, just let it happen. Yeah? Become aware of it, and eventually it goes away. And of course, it takes a long time to get used to this veto power. And you start training your mind, though. As your mind gets more and more adept, as you come back into regular life, you start seeing, oh, I've trained my mind. And then someone comes and yells at you in real life, you find that I'm not angry anymore. I didn't react in the same way. All you did was change those connections. You changed the conditioning of the brain. When someone comes and yells at you, try not to react. And why this is so difficult is because we have this misconception. We have this misconception that we are ourselves, that we have this body, that these emotions are me, that these feelings are me, and we have great attachment. And that's, again, what that consciousness discovery showed biennial said. We predict that everything that we experience is ourselves, because that's what sustains our survival. But in reality, it's just a process. It's happening. Okay? You can say it yourself, you cannot say it yourself, it doesn't matter. It's happening. And if you can observe that it's happening, you see something different. You see that these processes are always changing. And with change, if you just watch it like a movie, it's okay. It's not as bad as you thought it was. And that's kind of how these things come together in my view. Yeah, my purpose today was to give you an idea. You can study the brain on paper with images, with techniques. You can study the mind using psychology, using cognitive neuroscience. But if you really want to understand and change the behavior of the mind, it's something that you have to embark upon yourself. No reading, no writing, no intellectual discussion can do it. The brain has to physically rewire itself, and that means you have to go and experience what's happening inside of you and change your own brain, change your own mind. We'll leave that for now. So again, I close with this message from King Abdullah. We want to be one of the most righteous people who brings a greater good to community. We have this gift. This gift is a great gift that King Abdullah gave to us. And he created it. So in the teaching of the Holy Quran, we created mankind to come to know each other. And if you cannot know each other until you first know yourself. Okay, thank you. Okay, we can have questions, discussion, as you like. Yeah, Mike.
I thought you were a combustion chemist.
Yeah.
Did this really just come from your personal interest in this?
Yeah, I mean, this is like my hobby. Yeah, it's a pretty boring hobby, right? Sit on a mat, meditate, go read neuroscience papers. Yeah, these are like I started when I was like 23. And it's my hobby. So 15 years or so I tried. And
I think the meditation as a hobby is different than reading the neuroscience papers.
Yeah, but I'm trying to understand what I experience.
That's cool.
Yeah, I'm trying to understand. I'm trying to see what is the science telling us about our mind and brain. Are my experiences in agreement? Or many of the experiences you have are hallucinations. Who knows, right? So not to say that I have it all figured out. And I think that's also what neuroscience is saying is we might be able to image certain parts of the brain, but the connections are so complex. Yeah. And there's another talk by, I think her last name is Lloyd from University of British Columbia. It's in my backup slides. Here it is, Laura Boyd. Yeah. So many things like learning behavior and exercise, we know that they're good for us. Yeah. Neuroscience shows it, but we know if we learn new things, we create new connections. And people have thought, okay, does that mean we can create medicines or therapies to resolve things like deficiencies in learning, behaviors like depression, get people to exercise more? Yeah, but it's not that easy. Also, now modern neuroscience is showing it's not easy because every individual is so different in their neural corrections. There's no one-size-fits-all solution when it comes to treating the illnesses of the brain and the mind. It's very complicated. And and that's kind of what I'm trying to understand. There is no one-size-fits-all solution. I try to understand myself. I try to go to the literature, understand what they have there. And it's not related to combustion chemistry, but actually I believe it is. Yeah, I believe everything is chemistry in the end. So in the end, I think it's all in the astrocyte. So that's what I'm trying to talk to Pierre Magistrati about. Because really, it maybe all comes down to only chemistry. And what is combustion chemistry? Oxidation. What is oxidation? Metabolism. Yeah? And what happens in cells? Metabolism. So low temperature combustion chemistry. Yeah? Long stretch, right? That's a hypothesis. That's a hypothesis worth testing. Who's going to fund it? June? No?
I wanted to ask if you can highlight what this veto power is, because until now it sounded like that this is the part where free will comes in, or
free will or free won't, however you say. So like the idea of an action, what we want to do actually, besides the Leibniz experiment, more even advanced studies in functional magnetic imaging have shown many actions, many things, even emotion, may happen long before we become aware of it at the conscious level. What we believe is conscious, what we say is I. So in that sense, we can't really control the arising of these types of things. They're going to happen. But what you can do is when it happens, if you're aware, before the action happens, before the reaction, we say, happens, we can stop it. And that's the Leibniz experiment, that I want to move my hand. The decision is made to move, but you can stop the movement when you become aware. So you can choose still at the end to move or not to move. It's not really that you will the action, is that you unwill it from happening. You say you're not going to make it happen.
So the only freedom is unwillingness.
It's a philosophical question. Yeah. Many people that Leibniz experiment for that reason. Many philosophers. My view. You can. What I believe and what the Leibniz experiment does not show is that that time delay. This time delay can change. Yeah. So what happens unconsciously, and what we have experienced, I've experienced in meditation and many other people, is that you can become aware of things happening much earlier. Yeah? And that's kind of how it helps you. Rather than waiting to the last moment when all of this sensation and all of this emotion is built up and it's all ready to manifest itself as an action, you stop it earlier. And so that's what I think we're trying to do. We're trying to understand what's happening, experiencing what's happening in the subconscious mind at a very deep level, outside of our normal awareness, and control those behaviors before they arise at a very gross level. But yeah, it's a philosophical question. It's worthy of another PhD. Yeah? Yes?
How many times did the white people actually hunt the bull?
I think it was 14. You can watch, it's on YouTube. Go watch it. 14 or so. Okay, good. No. Yeah. But what modern cognitive, psychological therapy is showing is that emotion, just putting a name to the emotion, yeah, has a lot of therapeutic effect. Psychology is showing they come with people with extreme depression, and depression is not depression. People thought before depression is one kind of depression. We'll give some medicine, we'll get rid of the depression, but they know it doesn't work. Yeah. In the long run, it's just treating a symptom of the depression. But depression has many shades. Loss of a loved one, due to illnesses or sicknesses. So many different types of depression, and a good cognitive psychologist tries to categorize, tries to understand the individual and see what type of emotions is this person feeling. And the Atlas of Emotions has thousands of new words in the language of English to describe emotions that are very complex. But they found that just naming these emotions and giving the person some understanding, the neocortex then starts to play a role. It starts to adapt. It says, oh, this emotion, it exists. It's part of my physiology. It's part of my psychology. I understand it's part of my culture. It's not something that's just made up. And that's enough for the brain to change sometimes. That's sometimes enough. So we talk about neuroscience, but a whole other aspect of it is just psychology and therapy. They try to understand how the brain behaves so they can do the right types of therapies then for the brain to overcome different types of things. So we should not think that we're trying to stop certain types of emotions. We're not trying to get rid of emotion. We're an emotional being. But we're trying to recognize. And certain types of emotions elicit wrong types of actions. And we don't want to make wrong actions. Yeah? Our goal is to make the right type of action that will bring benefits to others. But we are conditioned always, that we make these wrong actions. It's part of our physiology and our psychology. So when I say from a personal perspective and a practical perspective, I try to observe what's happening. There's no point in trying to get rid of it. Yeah? But don't let it manifest in an action that's detrimental to your own benefit and benefit of others.
You've given many examples about mitigating negative things by understanding the street
absolutely,
itself. Me doing an action, forgiving someone, understanding how to come out of depression. Do you have any examples of, sort of accentuating the positive? How the mind can be used to, improve one's happiness.
This process, you have this wisdom. Once it's attained, you realize, okay, I have negative thoughts, I have negative behaviors, but I also have positive behaviors and positive thoughts and things like compassion and altruism and forgiveness and kindness. And these are things that make you happy. The body map shows they make you feel very good. So why not, when these states arise, enjoy them and try to increase them? Yeah. And that was the last TED Talk. If you want, we can watch it at the end. But many people are born already with these types of. Everybody's different. Some people are born in great misfortune, but they're very happy. They're very thankful and grateful and compassionate. And their brain is wired that way. That's good. Many people are born with great fortune and are very unhappy, very miserable. That's how their brains are wired. So, but we have neuroplasticity. We can change. Yeah. So when good states of mind arise, good feelings, understanding, you can practice those things. But I think the important part is you need to get rid of the negative part as well. So very important to cultivate the positive, but it's very difficult to cultivate the positive when there's a lot of negative as well. So remove the negative and cultivate the positive. You guys do both. Yes?
So you encourage us, and I totally agree, to train ourselves differently, to train our brain in different ways to acquire new awareness.
Yes.
So sometimes, if, for example, you know two languages now, or one language, and you want to really understand, you don't have another language, you lose on the first language. Sometimes, if you train to be a bodybuilder, you may not be as good in running marathons.
Yeah.
Is there any, if you do that training, and I certainly think I think everybody should do it, but is there something you may lose? Any capacity, for example, for social interactions, or making decisions, being more risk-averse? I don't know.
It could. I mean, I don't know. It's a practice. Like you say, running a mile every day or lifting weights. Of course, anything done to extreme. I'm not a monk sitting in the mountains for 30 years. Leaving my family, that might be a bit extreme. But, it's another exercise, a mental exercise. And, yes, if you take this type of exercise and you come into daily life and you say, oh, this is a miserable person, I want nothing to do with you, and you just walk away, that's not what we're trying to get to, right? Your purpose is not to avoid situation. We are a social being. We have to interact with others. You have to understand other people react to situations the same way you react. And the goal is, rather than reacting in negative ways, but to be more positive in those situations. So the training is to train the mind for some time of the day. I practice twice a day. To not react to certain types of situations. So that when I go out into regular life, when I go out into the real world, when I go and interact with others, to be somebody that's more productive for the society rather than unproductive. More productive for my family rather than unproductive. If you take it too far, and trust me, you will take it too far sometimes. And it happens in meditation. 15 years of practicing this, times do come, where your brain starts playing games with them. You might go for meditation and think you're enlightened when you come back. And that's, again, another game the mind is playing, the brain is playing. A self-centered view that I'm a wonderful person, I'm very smart, I'm very intelligent, I'm enlightened, everybody else is miserable. That game happens. But it's just another experience of the mind, another experience of the brain. which is detrimental. And you need to realize, oh, this is just another hallucination of mine. I come back and all I'm supposed to do is see what's happening, and eventually that goes away as well. So the practice in its pure form, I don't see it can bring any negative aspect. But of course, we are conditioned as human beings to do things incorrectly. And I guess the whole objective is to try to understand when we're doing things incorrectly, try to remedy the situation, and move forward. Yeah, Idris.
Thank you for the speech, man. So you did mention that it is possible to reprogram yourself as a result of neuroplasticity. So I'm just wondering, how would you, could you comment then on the possibility that certain personality disorders actually have a kind of physical correlate in the brain, perhaps some part of the brain that has been damaged?
Yeah, so I mean, if you look at images of people with depression, the hippocampus is typically smaller. It's not as active as a person that's healthy. So definitely, many mental disorders have their roots in physiological observations in the brain. People who have lost memory, typically the lateral lobes, there's some brain deficiencies there. So indeed that happens physiologically, but what I think, and also modern therapy in terms of depression, is to help the individual create the neural connections which will help the hippocampus to regrow, to become of a healthy size. And there's more talks you can see, again from Boyd, about things like benefits of exercise, yeah? Yeah, things like exercise, cardiovascular exercise increases the amount of neurotransmitters in the brain, and this helps to create new types of connections, also helps with neuroplasticity and therapy. So definitely, people with mental disorders do have some physiological deficiency, but what the modern therapists are trying to do is to resolve those, try to understand which parts of the brain are damaged, what types of therapies can help to rectify that situation. And in terms of self-observation, I can tell you, things like addiction, sadness, depression, also within yourself, you can experience these things and you can observe them. And again, if you don't perpetuate the cycle, if you observe it, there was a point I was depressed for about a year, and you observe it, and but the problem is we identify with it, right? And then we stick with it, and we keep being depressed and keep being depressed, and for years on end. And the goal is this depression came, maybe some deficiency in the brain at some point, some experience, some past experience, but eventually it goes away, and the neural connections can modify themselves so that you're happy again. And you can either do it therapeutic, or you can do it to yourself, self-therapy, we can say. Yeah.
So, sorry, yes, let's go for a couple more questions, and then I invite you to talk to... yeah, we can talk after, directly with the speaker. Thank you. So a couple more questions. Falken, please.
You're not caught up in trying to eliminate the negative or being, attached to the positive. You just develop a distance between all these emotions.
Yeah, in these types of courses, that's a common word that's used, equanimity, and that's a term that's used, in the framework of when you're meditating, during the period of meditation, because if you want to experience this impermanence, one has to observe something objectively. You cannot be reacting to negative things, and you cannot be reacting to positive things, because once you react, you're no longer a silent observer. So equanimity is a term used to be an objective observer of what's happening. Indeed, during meditation, we want to practice this. But in real life, when there are certain states of mind which would benefit others, there's nothing that prevents an ardent practitioner from improving and cultivating those types of positive states of mind. Indeed, though, one understands that this positive state of mind, this positive behavior exists within me. It's also impermanent. It may go away. I may be able to improve it, make it better, but sometime it will go away. And if it goes away, you're not upset about it. Yeah? Eventually it goes away. You experience the impermanence of positive situations as well, and you carry on. So, then life becomes much more enjoyable. It's like a movie. Things happen, bad things happen, good things happen. We have no control in what's happening, but we have control over how we react to the situations. And we can react positively, negatively. Equanimity doesn't mean you react. You don't react. Okay, that's a common misconception. When you say equanimity, I don't react to a situation. No. The purpose is to not react negatively. Yeah? And when something happens that's positive, you can enjoy it. It will last for some time. Eventually it will go away as well. That's equanimity. Okay? Last one, Bruno's going to call the person. Yeah. Yeah, I don't know the answer yet for that. I mean, this is also the thing is, again, the things are very complicated. And again, I talk to you only about what I experienced. There's many things that other people might have experienced. If you go talk, they may talk about it. But I don't know the answer to that. I only know what I've experienced. I still don't know, who I am. Okay? I have some more understanding than I did 15 years ago, but I don't know yet. And I don't know veto power, this consciousness stopping action, where that really comes from. I don't have these answers yet. But again, the neuroscientists would say, these are all, even I listen to some modern neuroscientists and Dawkins and people with cognitive psychologists, they'll talk about all of this just being a construct of the physiological aspects of the mind and the body. And but I don't understand all those things, so I cannot comment on them. So who does the veto power? What is it really? All I know is it's there. I know I can be aware of something. I can stop it. But where it comes from, what's its origins, I don't know the answers to that. And I don't think you'll find a journal paper about that either. It's philosophical, right? Many things are still left to philosophy.
Right. Please join me to thank the speaker for his insight.